Let's begin episode 2 of Learning LangGraph via storytelling. So, if you recall in episode 1, this is a whole story about Sam coming to this new village and he has a problem. He wants to host a festival, but he doesn't know whom to go and what are the preparations that he needs. So, that's what now we will bring that story from that episode 1 to episode 2. And in this episode 2, he's going to meet LLM node, which is nothing but librarian. And librarian is going to explain him, Sam, if you want to plan event, you need to have this much checklist and you have to prepare accordingly. Maybe you might want to check the weather as well. So librarian here is acting as a LLM node where here we would be calling the LLM the model and then we will get the response from LLM. Plus, we will explore the conditional ages. So let's directly look into what you're going to build in this episode too. Here we are not going into much very basic of LangChain or LangGraph setup because that we already covered in episode 1 if you want to check that out. But let's directly see what we are going to build in this one. So I'll directly run this guy. Hi, I am I am Sam, for example, right? And then this is what Sam gets reply from the assistant. Assistant is nothing but Sam is getting reply from this guy, greeting, right? So this is what we build in episode 1, right? But we are in episode 2. Now here the Sam tells the problem. I want to plan music event this weekend. For example, that's the problem, right? Now that's where now this will be called, this will make a call to the librarian, right? And we got a response. So now this is a reply coming from GPT-4o mini model where it just gives a checklist. Yeah, Sam, if you want to plan an event, then this is a checklist. You have to choose a venue, artist, and you have to choose the weather conditions and blah blah blah, right? So I'm just trying to focus more on weather conditions because that's a food for our episode 3. So this is what you're going to build, where here you're going to learn about the conditions, right? And you're going to learn about how to make a call to the LLM model via LangChain. So that's the two food for this episode 2. So let's begin quickly understanding this code. We are just doing a necessary imports done. And yeah, this is a Sam imported. So, and that's the librarian. Yeah. And then we load the required variables. Make sure you load your own key, otherwise you will get this guy. We always start with line graph defining a state. So this is a state. If you want to get more details about state or what is add messages, please check episode 1. Otherwise, this episode will go bigger, where I have explained annotated and everything, right? But here we are defining state. State is defining as a messages variable. So this is a messages variable which just goes from one node to another node. So for example, I'll just jump it by looking at the diagram. It would be easier. So Sam coming into picture, and then Sam wants to host an event. It's he is greeted by the greeter, and greeter tells Sam the message, right? This is a message by greeter, right? So this is a message added by this node called greeting. Now here every node is acting as a function, right? That's what it does. Simple. So greeting tells that yeah, Sam, welcome to the this village, and then it gives more message. Then after that, greeter asks her, what do you want to do? So now Sam has to give input, right? To capture the Sam input, we have another node which is nothing but user input. And then from that user input, in this video, we are adding the router node. So the router node job is to scan the user input, check if the user input contains any word like help, plan, event, anything. If those word is there, which means Sam now needs librarian. So then it will route to the library route. If nothing, other case, we simply end the flow. That's how the flow works. So now coming back to the code here, right? So once greeter gives the message to the SAM, right? This is what we are printing, and then this is what we are returning. So this is how we are modifying the state, right? So the moment when we modify the state, which means messages is here, right? So when this node, greeting node is modifying the state, then this node, user input, this gets the modified state as input, right? So every node basically gets the state and then it modifies and gives the modified state back to the next node. That's how the line graph works. I mean, if you want to create really like stateful applications. And then here, this is where the user input node comes. And the user input node, that's where Finally, we are asking Sam, but Sam, what do you want to do? So Sam gives the input. We again add that input into this user input node, right? And then finally comes, not finally, but then router node comes. Router node basically checks the user input. Here, what we are checking is that from the state variable, right? From the state variable, we are checking the last message. Last message is nothing but what Sam added, right? We convert into lower and then we just simply check, does the Sam message contains this three, right? If yes, then it should go to the library node. Otherwise, and here comes the library node, and that's where, so for example, Sam might have said one of these three words, right? So it goes to the library. Now, library node here, we are making a GPT-4o mini model. Ideally, you do not need that, right? For solving this problem, but we are trying to show you a demo via storytelling, right? How the LangGraph works, how a node can actually make a call to the model, right? LLM model. So this is where you define a system prompt. You are telling GPT-4o mini that, hey, GPT-4o mini, you are acting as a librarian, you are one of the wise person in this village, and this is background of the village, right? That's what you are giving. And finally, sorry, finally we just we just call the invoke method, and we pass system prompt and we pass the state. That's all the messages of Sam. We get the reply back in the result. We print the whatever the LLM model gives response. We print it as output. Again, we modify the state variable by adding the library message, right, or the LLM model message. We add that message back to the state variable. Finally, time to come to the construct the graph where we are adding all the graphs. So like we are adding the greeting node, we are adding the user node. Only the thing which we should maintain is that this can be any text variable, but this will always match with the function what you've created. So like here I can put like XYZ, but this greeting node is nothing but it has to be this guy, right? So you are basically adding all the node. Now this is a little bit something special because here only thing is when I was trying to add the node, right? So every node should output as a dictionary. It should output the state, right? So it was not allowing me to add the node. So that's why here I am just using lambda XX, which is nothing but whatever is the input. I am not modifying anything in input. I am simply giving the same input as output. That's why I have to add this. Otherwise, this router is actually returning string, right? Because it's a condition node, if you remember, right? So it just return library or and, right? This is the router node it does, right? And library node. So we just simply add greeting node, user input node, router node. Now time to come to draw the edges. So that's the beauty of LangGraph, right? You can really visualize the code. So now what I'm going to do is I'll add age from greeting to user input. Simply check here, right? So add age from greeting to user input, then user input to router. And my starting point of the LangGraph is greeting. Now that's where comes the conditional ages. Now time come for adding this and this, right? So from my flow starts from here, right? When Sam asking message, it passed through all this path, right? When it comes to over here, now there are two possibilities. Either it can go from here or here. So that's what we call it as conditional ages. Now we are adding conditional ages to the router node, right? So router node is nothing but the source node. So that will be my first argument. And it should match with this guy, right? This is what I'm doing. But now where is the business logic? Which means how, or there must be some business logic which will tell, that if something happens, then you go here, or something else happens, then you go here. You follow this path. Now that is captured already, if you remember, right? We captured in router node guy, right? You remember this too? Yes. So that will become my second argument. And here, second argument, it should match with where is the router node. No, it shouldn't match from here, but it should match from the here, from the top, right? This is what should be. It's a function. Now this function is giving two output, right? If you recall, either it gives library or either gives and. So whatever the string output that you define from in this function, you have to match on the right hand side with the corresponding node you want to execute. So if it's library, then you want to execute the library function, right? So or library node. So that's what you are trying to tell here. Because ultimately, if this function is giving you library, then you have to execute the library node, right? So that's why Here you are defining library. Library is nothing but actually you are trying to refer to the library node. So you might get confused where I am using this guy, where I am using this guy. I think mostly we would be using the name only, the XYZ name only. We would be using the reference only, not the actual function, at least in this part. So if it's library, return value from this router node, right? If it's library, then we use the library node function. It's here, right? And if it's and, right, then we simply end the flow. Now, if, for example, imagine I want to just quickly ask you a question. For example, if it's a flow that if it's library, if router node returns value library, returns string value library, then you want to call greeter function. What you do? You will simply go over here, you will put greeting over here, right? You will put greeting over here. So it will call the greeting node, right? That's how it works. And finally, we don't want library node to hang in air, so we simply connect library to and as well. How we do that? Like this, library to and then finally we compile the graph. And yeah, this is we are just simply testing the whole flow end to end. And finally we just invoke. Finally we just call the invoke method, and then we passes the messages. Messages is nothing but messages contain the user input. Right, this is my user input. I am just adding user input back to the messages. This messages I am passing to the app.invoke method. So that's how it runs. The whole LangGraph flow where each node is trying to solve the SAM's problem. And here in this video, you learn about the conditional ages. You learn about how to call LLM agent, right, or LLM model by by any node. So stay tuned for episode 3 because in episode 3, what we are going to do is that now Librarian needs to check the weather only when Sam asks for it. So Sam now might ask, but what's the weather is going to be like? So now LLM will call the tool node. So that's the new concept we will introduce in episode 3. So stay tuned. This whole sheet is added as a in the description so that you can play around. My GitHub link is there. You can play around with the code and shoot me a comment if you really want to know any concept in Python, GenAI, machine learning. I can storify it. I can explain you. So just stay tuned and shoot a comment so that I can just get more idea what you like it, what you did not like it, so I can improve as well. Thank you.